What's up? Welcome back to part two of my final. See how this is going. Just finished problem number one. It's Eli Loft again, by the way. Gotta get that out there first. So like I said, I went through all of the problems in my first YouTube video, like explaining the step-by-step of what they each mean. I That was before I realized that I need to do separate YouTube videos for every problem. So I guess the just for this one, I looked over all of them. The problem number two is over prime numbers. We want to get all of the prime numbers in order up to a certain number. So let's go ahead and look at the initial problem. Let's see. Hmm, so it doesn't give us much for starter code. That's cool. We don't need it. Prime numbers are pretty easy. It's a pretty common algorithm. Just and yeah, let's get started. So when given a definition of prime, given variable, or sorry, parameter of n, which n is the highest number, we want all the primes below n. Um, Down here, and then if n is less than 2, we want to return nothing. So we're going to return just an empty list. It's got to be a list, not a set, because be a list because, and not a set, just because a set would have them out of order, and it did specifically say in order. But yeah. So now that we got the initial test case out the way, um, we are going to also, just so you know, it's not my original algorithm. This is something that I saw a while back. Essentially, it's one of the faster ways to find a list of primes. Um, Going through, it's essentially going to put all of the numbers of n plus 1 into a list of numbers and mark them all as true, which is what I'm doing right now. I'm gonna make p equal 2, and then while p times p is less than n, which is our total number, essentially because like if our number is 50, the highest thing that we can have is 7 times 7 equal 49. So you don't actually have to check past uh, multiples of 7, because once you've done that, I've gotten all of the multiples of 7 out, nothing more can equal that, right? When it's multiplied by itself. Uh, and I'm going to do this in the range of the numbers that we have. And if it is a prime, we return it as false, just uh, yeah, and then we do this for collecting all of the prime numbers, and that's what we got. Um, so like I said, let's start by putting all these numbers to a list, making it true. Uh, I believe this is a Euclidean algorithm. Not completely positive. This is something I saw a while back when I was looking at coding videos for leak code interviews, which sounds really lame when I say that out loud, but honestly, who's listening? It's two, and like I said, well, essentially, and what this is supposed to say is if prime of p is not changed, then it's prime because, and then it's going to update all multiples of p to false, indicating not prime. So let's do this in a range. Okay, and now all we need is a couple of test cases. So we're gonna print. To 50. And there was no given test cases, so we're just gonna review. 50, let's do 30. Let's do 1. Yeah. Cool. That looks correct. Yep. This one's all ones up to 7. This one's going to be empty because it accounts for numbers below 2. And then this one is going to be all numbers up to 100, right? This one works. Lock it in the vault. And with that, it is time to go to the next one.